Hi guys, I hope you're doing great, and in this video we're going to be discussing about how are we going to draw a demand curve using the marginal utility principle or the Equi margin principle with a two commodity version. That is, if there are two goods, how will we plot the demand curve? In the previous videos we've already seen how to plot a demand curve, but that was for one commodity or single commodity. Now we'll see how are we going to use the Equi margin principle, and then how are we going to how are we going how will we translate and how will we put those values on a demand diagram using the optimum bundle that we have already calculated using the Equi margin principle. Now guys, if you haven't seen video 9b of the utility playlist, I would suggest you stop this video, go back to video 9b, you watch that video, and then you come back over here. Okay guys, so in this video basically I have used the same values that I had used for video 9b since it's a continuation. So if you guys remember that good A was for how much? Good A was for $4, while good B was for $2, and I have mentioned the number of units, the same that I had mentioned in 9b as well. The marginal utilities are already given, and the marginal utility per dollar is also calculated respectively for good A and good B, right? And if you guys remember that the optimum bundle was how much? The optimum bundle was 3A and 2B. That is, I was getting a total utility of 290, which was the maximum utility, and I had given my income constraint or given my budget constraint. So my budget constraint, guys, was $16, and given my budget constraint, I was maximizing my total utility, that was 290 utils, and I was basically buying 3A and 2B, and this was my optimum bundle using the Equi margin principle, which says that the marginal utility of A over the price of B should equal the marginal utility of B over the price of B, which makes the consumer indifferent, and then his next purchases, or you can say his per dollar spent on either good A or good B, is the same as that would actually result into the same marginal utilities, whether that $1 is spent on good A or the $1 is spent on good B, and then the consumer will actually buy good A and good B both, and then respectively exhaust his total income, and which will lead him to maximize his total utility as well. Now guys, having said that, let's draw a demand curve. We know that his optimum bundle is 3A, that is, he's buying 3 units of A and 2 units of B. So I've drawn a demand curve. It says quantity demand of A. So basically on the demand curve, on the price axis, we have written $4 because the price of good A is $4, while the quantity demanded of good A is 3 units, while the quantity demanded of good B is 2 units at a price of $2. So I've respectively drawn the demand curves. I've said, okay, fine, price of is $4 and $2 in the respective quantities. That was the optimum bundle is also mentioned here. Now guys, let's now the good part is that let's assume. So initially the price of good A was how much? It was $4, and now we are assuming that the new price, that is the new price of good A, is how much? It is now $2. The price falls, it falls to how much? It falls to $2. So let's suppose that the price of good A falls to $2. Now what we will do is that we are going to calculate the new marginal utility per unit. Sorry, we're going to be calculating the new marginal utility per dollar. So guys, now we will calculate the new marginal utility per dollar, and that would be mu over P1, right? And the mu is how much? It's 120 for the first unit, and the price is $2 since it has fallen. So the mu will obviously be the value would obviously be higher. It would be how much? It would be 120 over 2 would be 60, 80 over 2 would be 40. This would be how much? This would be 20. This would be 16, this would be 16 divided by 2 would be 8, and 4 divided by 2 would be 4. So guys, you've automatically seen that whenever the price of the good is going to go down, the marginal utility per dollar will go up. Remember this rule: when the price goes down, the marginal utility per dollar goes up, and there's no rocket science in it, and it's simple maths that the marginal utility per dollar is calculated as mu over p. If the price is going down, the value, and this stays the same, obviously what is going to happen is that the value of the mathematical value would obviously be higher, right? It's just the same principle. So now what we see is that the marginal utility per dollar has exceeded, and now what we are going to do is that if the price of good A has fallen from $4 to $2, now we will see how are we going to maximize our utility, total utility, and what will be the new optimum bundle of goods. Now as far as the first unit is concerned, guys, as far as the first unit is concerned, so let me change the color, by the way. So as far as the first unit is concerned, the first unit, should the consumer buy good A or good B, obviously now we are going to take the new values, that is the new marginal utility per dollar for good A, because now since the price has fallen, the marginal utility per dollar spent has actually gone up to 60, right? So the consumer would actually, and 60 is greater than 15, so definitely the consumer is going to buy the first unit, that would be good A, and respectively he has spent $2 since this is the new price. Now comes the second unit, so he has bought this unit. Now comes the second unit, obviously he would still buy A. Why? Because 40 is still greater than the first unit of B, which is giving him a marginal utility per dollar of 15. So he has bought the second unit as well. Again, he has spent $2 on it. The third unit is again giving him a higher marginal utility per dollar of 20 compared to the first unit of good B, which is 15. So obviously we are going to be comparing it with 15. Why? Because he still hasn't bought any good B, right? So again he has spent $2 on it, and in total he has now spent $6. Now he's only left with how much? 16 minus 6, $10. Now comes the fourth unit. The fourth unit gives him a marginal utility per dollar of 16 as compared to the marginal utility per dollar of good B, which is 15. Still 16 is greater than 15. He would still buy good A. Again he's going to spend $2 on it. So he's now bought respectively 4 units of good A. Now comes the fifth unit. He is now going to buy, the fifth unit would be of good B. Why? Because the first unit of good B is yielding him a marginal utility per dollar spent of 15, while the marginal utility per dollar of the fifth unit of good is only 8. So obviously a rational consumer would buy good B now, because that's yielding him a higher marginal utility. But again, it's for $2, so he spends $2 on it. Now comes the situation. Now in total he has spent how much? He spent basically he's bought 5 units now, and he's actually spent $10 now. Now comes the sixth unit. So the sixth unit could be the fifth unit of good A or the second unit of good B, and obviously the second unit of good B is yielding him a higher marginal utility than the fifth unit of good A. So as far as the sixth unit is concerned, he is going to buy the second unit of good B, which is 10. That has a higher marginal utility per dollar of 10 as compared to the fifth unit of good A, which is yielding only $8 utils per dollar, right? 8 utils per dollar. So he buys good B again he spends $2 on it, which is fine. Okay, now comes the fourth, fifth, sixth, seventh unit. Now it is returned to buy the seventh units, because he still has some money left. He has bought how much? 1, 2, 3, 4, 5, 6. He's bought 6 units. 6 times 2, he's already spent $12 on it. He had $16. Now he is only left with $4. So right now he has to spend his $4 between either buying good A or good B, or a combination of both. So now if you see, now he has the option to either go for the fifth unit of good A, or he could go for the third unit of good B. Now what we see over here is that the marginal utilities per dollar of the fifth unit of good A and the third unit of good B is now the same, which means that the equi-margin principle is now satisfied, because the consumer has reached the point where the marginal utility per dollar of A is basically equal to the marginal utility per dollar of B, right? And since the marginal utilities per dollar of both the goods are now equal, it means that the consumer is now indifferent. He could either go for A or he could go for B. So let's say if he goes for A, right, he spends $2 for it, and now he's only left with $2, which means he's going to go for B now, and now he buys, and from his $2 he now buys another unit of B. So he's basically bought this unit, and he's also bought this unit, and he's also bought the first 2 units of B. So now the equi-margin principle says that a situation has come where the marginal utilities per dollar are equal, and hence the consumer could either go for A or he could go for B. So let's say he goes for A, now he's going to go for B, and hence he is going to exhaust his limited budget of $16, and hence as a result the new optimum combination that is going to yield him the highest utility is how much? Let's see how many A's he has bought. He's bought 1 good A, second, third, fourth, fifth. So he's bought 5 units of good A, and how many units of good B? 1, 2, and 3. And he has bought 3 units of good B, right? He's now got 5 units of good A, and he's got 3 units of good B. Now let's see what will be the total utility if he buys 5 units of good A. So obviously he's bought the first 5. I mean, he's bought the 5 units of good A, which means that how much utility has he gained? 120 plus 80 plus 40 plus 32 plus 16, which means that as far as good A is concerned, his utility should be 120 plus 80 plus 40 plus 32 plus 16, right? Now I'm not going to be doing the calculation, you can do it yourself as well. And he has bought, and whatever the answer is, right, you're going to add this with the utility that has been gained while consuming 3 units of good B, and 3 units of good B have led to a utility of 30 plus 20 plus 16, that is 30, 20 and 16. That is how much? That is 30 plus 20 plus 16. So you're going to add them up, whatever the values are. So this is going to be the total utility that he has gained, and obviously this total utility would be higher than total utility of 290. Why? Because now let's see, because initially he was consuming 3 units of good A when the price was $4 for good A, but now he's consuming 5 units of good A since the price has fallen, and he initially was consuming 2 units of good B, but still, since the price is still the same, but still he is now ended up buying more units of good B, which again gives us a lot of principles of demand as well. In fact, let me just calculate the value of total utility. So guys, the value of total utility would be 120 plus 80 plus 40 plus 32 plus 16, and that comes to how much? It comes to 288, while this comes to 30 plus 20 plus 16, this comes to 66. 288 plus 66 gives me a total of 354. Wow. So initially when he had bought how much he had bought 3A and 2B, he gained a total utility of 290. Now he's bought 5A plus 3B, he's gained a total utility of 354. So his utility has gone up by how much? His utility has gone up by 64 utils. Wow, that's great. So the thing over here is that if you ask me that why did he end up buying more units of A, is because the price of A simply went down. So the reason why he ends up buying more units of good A is simply because the price of good A fell. Since the price of good A goes down, he ends up buying more units of good A. But at the same time, we can also learn or conclude from here that although the price of good B has not changed, but still the price of good A has actually influenced the number of units that he could buy for good B. And the simple reason is that since the price of good A fell, he was left with more money to spend initially that he could now spend on good B. Because the price of good A falls, as a result, his amount of income that is left to purchase other goods is also increasing, right? Because now he has more money to spend on other goods as well. So although yes, the price of good A falls and he's consuming more units of A, but then obviously he won't just consume good A, he will also spend a part of that money that has been that is now left with him in a greater quantity on good B as well, right? And what the consumer is simply doing is that he's substituting good A and good B, and with good B and good A, and then comes a point where the marginal utility per dollar are actually equal, right? So if I was to actually, I'll just erase this by the way, if I was to actually sort of draw this on a diagram, I am saying that the price of good A goes down. So if the price of good A goes down from $4 to $2, the quantity of good A goes up from 3 to 5, right? So now he's ended up buying 5 units, and simply again we can say that the Equi marginal principle results into an optimum bundle, because of fall in price resulted into a higher marginal utility per dollar. And basically you write in the exam that a fall in price resulted into a higher marginal utility per dollar, and this results into more quantity of good A being bought, and we can show this on a demand curve as well. This is what actually the examiner wants to see in your answer. So you will say that results into a simple extension in demand from 3 to 5 units, and this is the optimum combination. 3 was initially the optimum combination when the price was 4. A fall in price results into higher quantity for good A, and the simple reason is that the marginal utility per dollar of A fell. When this happened, it means that each additional dollar spent is giving the consumer a higher marginal utility. So the consumer started buying more of A. But the problem is that as he starts buying more of A, we know that the diminishing marginal utility kicks in. And when diminishing marginal utility kicks in, then the marginal utility per dollar starts to decline. But then again, if the marginal utility per dollar spent on A is still higher than the marginal utility per dollar spent on B, you still would keep on consuming A, to a point where the marginal utility per dollar of B is actually higher than the marginal utility per dollar of A, right? And so he starts consuming B more then. And then what happens if he starts consuming B more, then the marginal utility per dollar of B also starts to go down, till a point comes that the marginal utility per dollar of B is equal to the marginal utility per dollar of A. And when this happens, marginal utility per dollar of A, and when this happens, it means that the consumer is now indifferent between each dollar spent on either good A or good B, and that's what the Equi margin principle is saying, that the consumer has reached equilibrium. I mean, the previous purchases or all the purchases that was made up till now as far as good A and good B are concerned were made in the optimum manner, and we also saw that in the previous video as well in 9b, right? Now, if the price of good A goes down, his quantity demanded increases from 3 to 5. But what impact will this have on the demand for good B? The demand for good B simply shifts to the right, and it increases because the simple reason is that the consumer is now consuming more units of good B as well, and the demand curve shifts for good B. The demand curve will shift to the right because the price has not fallen, still the consumer is actually buying. So how many units of what is the optimum combination that he's buying for good B? That's 3 units. So he ends up buying 3 units. Simple. So as far as good B is concerned, you'll say in the exam that the demand curve will shift to the right because of a fall in the price of good A. So the reason why, because the price of good A goes down, the consumer is now left with higher real income. So the real income of the consumer goes up, and when the real income of the consumer goes up, he can actually spend more on good A as well and good B as well. But since the price of A had gone down, that would be represented through an extension. However, since the price of good B did not change, we will represent that through a shift in the demand curve, right? So remember guys, this is it. This is what I wanted you to explain, and you guys should know that this is how you basically are going to draw the demand curve as far as the 2 commodity version is concerned, and then you will show that a fall in price results into a rise in demand, a rise in quantity demanded for a product, and then that causes a shift in the demand for the other product, because the simple reason is that the real incomes have increased. And why have the real incomes increased? The real income for the consumer goes up because of a fall in the price of one particular good. So when the price of a particular good goes down, the consumer has now, that increases his buying power or purchasing power, right? So yeah, that's about it. I hope you understood this and enjoyed this video as well. I'll see you all around in the next video, where we will going to be covering the limitations of the marginal utility theory. So stay tuned guys. Until then, take care.